Assalamu alaikum. Our project is about area moment of inertia. It's the last chapter in the book. First, what is the area moment of inertia? The area moment of inertia is the second moment around a given axis. For all the element dA in the shaded area, the area moment of inertia determined by I can therefore be calculated from this law. If we have a rectangular cross-sectional system as shown, we can define the area for the internal around x and y and the area moment of inertia by the given law. This page from engineering machine static 7 edition. From this 2 page, area moment of inertia for 3 shape. There is a lot, but this we will use just in this in the example. First, for the rectangle area. Second, for the area moment of inertia for the rectangle. 2 for the triangle, and this is for two law for the centroid x and y. This for the triangle area moment of inertia, and this for the quarter circle area, and this for this law for the centroid, and this is for the area moment of inertia. Now we will have 2 examples about them.
Assalamu alaikum. Today we are going to talk about area properties. Here we have a simple example determine the moment of inertia around this point. Here we have 3 rectangulars. This is the first one, and this is the second one, and this is the third one. For each rectangular you have to calculate Ix naught and Iy naught. So these laws you can find it in the end of the book. Let's start with the first rectangular. So Ix naught equal 1 over 12 bh cubed. B is the base, h is the height, cubed, plus area multiplied by y is the distance from this centroid to the reference point, squared. That gives us 1 over 12 multiplied by 80, 80 is the base, multiplied by 20, the height, cubed, plus the area of the rectangular, 80 multiplied by 20 multiplied by 70, the distance from this centroid to the reference point, square. This is the result. For Iy naught, that equal 1 over 12 hp cubed plus ax squared. That means 1 over 12 h is the height multiplied by the base cubed plus the area of the rectangular multiplied by the distance from here to here, from this centroid to this centroid. The half of the 80 is 40 and the half of the 20 is 10. 40 plus 10 is 50 squared, and this is the result. For the second rectangular, this one, Ix equal 1 over 12 bh cubed plus ay squared. That gives us 1 over 12 multiplied by 20 multiplied by 160 cubed plus 0. Why it's 0? There is area, but there is no distance from y, so it's 0. And this is the result. For I, y equal 1 over 12 hp cubed plus ax squared. That gives us 1 over 12 multiplied by 160 multiplied by 20 cubed plus 0, and this is the result. Here we have the third rectangular. The third one is similar to the first one. They have the same dimensions and they have the same distance from the reference point. So they must have the same result. So at the end you have to calculate I bar x and I bar y. I bar x is the sum of the Ix for the three rectangular, this one and this one and this one. I bar y is the sum of the iy for the three rectangular, this one and this one and this one. And this is your final result.
In this example, we will determine the moment of inertia about x and y for the shaded area. This shape we can separate it for three. First for the rectangle, second for the quarter of a circle, three for the triangle. First we will determine the area for the rectangle. The area for the rectangle is space over the height, distance about x, distance about y, area for the dx, area for the dy, area moment of inertia for the rectangle. This law for the area moment of inertia for the rectangle, you can find it in the first of the video. You can second, we have a quarter of a circle. First we will determine the area of it. It's 1 over 4 pi r squared. Why it's a negative? Because it's a whole, and whole always be negative. Second, dx and dy, area about dx, area about dy, area moment of inertia for the circle, quarter of a circle. And this two law, first for the center, and second for the area moment of inertia for the quarter of a circle. Last we have triangle area, and it's 1 over 2 base over the height, area about dx, area about dy, and area about dx, and the area moment of inertia for the triangle. And this is the first law for the centroid, and area moment of inertia for the triangle. You can't find all this law in the first of the video. Last, we will put it in this table so we can calculate it very easy. This we have the resultant for the area, and the ADX and ADY and the area moment of inertia. Last we will put it in this law, and we will end our answer. Last, you should put the unit, because unit is very important in this chapter, because your answer may be wrong because of a unit if it's wrong. Thank you for watching, and have a good day.